Hello everyone, I am Hirunsirisawat from the Engineering Science classroom, the Hirunsirisawat School. And today, I am here to talk about a project I worked on in the past semester, which is the traffic flow simulation in the mixing of human-driven and self-driving cars. So, it began when me and my friends started to be interested in the field of traffic, and we decided to do some studies. Interestingly, we found a prior study suggesting that even without any interruption to the flow of the traffic jam can even appear out of nowhere, and this phenomenon is called the traffic jam without bottleneck. Most of the time, the traffic jam without bottleneck is caused by the behavior of the human drivers themselves, because humans have inaccuracy in perceiving of motions and distance while driving, and that always causes the problem. For the better understanding, I will voice over on the video from this Motorward. As you can see here, when the cars run along with each other on the highway, there is likely to be some drivers who change their speed in a strange pattern and cause the following cars to slow down even more, and finally there will be someone who is completely stopped. And that is where the traffic jam is started. So looking at this video, you can see that removing human will be the best solution to this problem. But it is almost impossible to give everyone a self-driving car that is really working. But luckily, there is a model designed perfectly for this situation, and it is called the FollowerStopper controller. A few experiments once showed that by controlling only one car on the road using this strategy, it can help dissipate the traffic jam in the whole system of a circuit road. But that brought us the question of how would it be like if we changed the number of the self-driving cars used with this strategy. So we set up the experiment in our computer using the simulation because we cannot afford to do the real experiment on the road. I hope you understand what I mean. And yeah, we create the simulation on our computer using Python. And we decided to use 24 cars running on the circuit roads, the same as the field experiment done, and we changed the proportion between the number of the self-driving cars and the human-driven cars. For the better understanding of how we simulate all of the stops, I will take you into the graphic. The part that is as important as the result is how we set up the simulations. But for the disclaimer, in this part, I am not the one who distributes the most on it. I mostly focus on working with the data analysis and adapting data and results into the practical ways. But I will try to do my best anyway. So, first of all, as you can see, we simulate the human-driven car using the intelligent driver model as suggested by Martin Treber, and we change a little bit of it to make it works on the computer simulation. And for the self-driving cars, we imitate the FollowerStopper controller using a set of conditions to make up how the self-driving car would react with the gap between itself and the leading cars. And for the parameters we use in the simulation, we decided to study from various papers in both statistical physics and also the civil engineering. And boom! There we got our simulation. Interestingly, the result turned out not as expected. The simulation that has the highest flow rate turned out not to be the one that all of the cars are controlled by the FollowerStopper controller, but is the proportion of 2 out of 24 cars controlled by the models. And we believe that this is caused by the strategy itself being designed to use in the mixed autonomy states. Or maybe the number of 24 cars in total in the whole system is not enough to indicate some of the factors. And all of this should be studied in some further research. But now, for now, this is the wrap of the talk on my project. And I hope to see you all again. Thank you for your attention.